Hello everybody, welcome to another episode of Biochemistry Capstone Videos by Spencer Hall, and I hope to graduate someday. Let's begin with a subject that is very basic and yet needs to be understood thoroughly to understand so much else of chemistry. That subject is atomic structure. And first we should learn of the building blocks or the subatomic particles that make up atoms, and there are those three main ones. The first one is protons. And protons are positively charged particles. They exist in an atom's nucleus. The nucleus is the tight packed center, and you can expect to find these protons in there somewhere in different numbers. Next we'll have neutrons. And neutrons are neutral, or in other words, they have neither a positive nor negative charge. These also fit into the nucleus. So let's put some of these in here, a number. And then you're wondering where the minus or the negative sign is. Electrons are your negatively charged particles. These, however, do not jam themselves in here. They swirl around, and they continue to move in something called an orbital. There are many different shapes of these. We're just going to go with the circle for now. Generally speaking, you will find that the number of protons, or positively charged pieces, will be the same number as the electrons. If we do not have that same number, then you expect a type of charge, and that creates an ion. But a question now is, how do you determine how many protons and electrons and neutrons you have in any given atom? Well, let's come to the periodic table of elements real quick and pick an element to use. We're going to pick a helium atom. Now you'll note on all of these, but let's look at ours specifically, that there are two main numbers. One is this one here. That is called our atomic number. In this case, it's 2. The other number is the atomic mass. In this case, ours rounds very closely to 4. So now let's head back to the board so we can use this information. When writing it in symbol form or in shorthand, you'd have a helium. The atomic number would fit here. In our case, that was 2. And the atomic mass fits up here, and that would be 4. But how do we use this, and what do these things mean? Our atomic number is the number of protons. And so for any given element on the chart, the number of protons in the nucleus determines the identity of the element. And therefore, in helium's case, it is the only atom that has 2 protons in it. If it were to lose one or gain one, it suddenly becomes a different element. And up here we have our atomic mass. An atomic mass equals protons plus neutrons. Now you might be thinking, well, what about the poor electrons that are swirling around the orbits? Do we not count them simply because they're not in the nucleus? And the answer to that is no. However, it's true that we do not count them. The reason for that, however, is these are so tiny by comparison to the protons and to the neutrons. So therefore, even if you have hundreds and 200, it makes a rather insignificant difference in determining the atomic mass. So that's why we count only protons and neutrons, and that's what you got here. Now, you want to know the exact number of neutrons that a typical helium would have? The answer can be figured logically by taking atomic mass, I'm going to write AM, and subtracting the atomic number. In other words, it's just the number of protons. And then you take that minus the proton count. In this case, atomic mass was 4. And our atomic number, or the number of protons we had, was 2. So 4 minus 2 equals 2. This atom I built here is exactly that, with 2 protons, 2 neutrons, and the same number of protons tends to apply here unless I denote otherwise. So you have 2 electrons as well. If I were to have an uneven number of electrons to protons, I'm creating something called an ion. If I were to say to lose one of these electrons, it floats off into space, well, that would be denoted right here, that we have an uneven number. And you would put up here the difference between protons and electrons. What does that mean? We have 2 protons in here right now. That's a +2. But we only have 1 negative right now, so -1. This is the proton count. This is the electron count. This is what's determining our charge. In this case, put these 2 together, all you're left with is a +1. Or in other words, there's 1 more proton than electrons, and you would put that up here. Lastly, to fill in our little square, this would just be the number of this atom in any given molecule or compound. So in this case, we only have 1. Technically, you need to write it, but you could have 2 if you put in a second one. Lastly, let's just do one last example to make sure we all get the idea. Let's come over here. Let's pick xenon right here. Again, this number on top is our atomic number. This is the number of protons. This is atomic mass, number of protons and neutrons. So remember, 54 and rounded 131. We're going to do the exact same thing to sum this up right here. Xenon, this is a difficult one, has a 131 atomic mass and a 54 atomic number. We know that this atomic number is the number of protons. And this here is protons plus neutrons. And so if we'd like to figure out exactly the number of neutrons that would fit in this nucleus, you would have 131, this number here, minus 54, which I believe equals 77. So that would be the number of neutrons we expect. Note that I did not put a charge here. Therefore, it would be rightly assumed that you would have the same number of electrons as protons. So I hope that this has been able to help understand chemistry a little bit, increase your desire to go after the best of all careers in chemistry. Thank you for watching.